I want to invite our other speakers and a very interesting talk. So, warm welcome once again to Dimpy Adhikary and Rashmi Konda. Dimpy and Rashmi will be taking us through again a very exciting topic about MQTT message testing, how to do that, and I think the topic is also quoted in a very nice way where hardware meets software and see how to do testing kind of such scenarios. Dimpy is coming from a very rich background of more than a 16 year of experience, and she's an excellent leader in terms of software quality assurance. She's responsible for developing, establishing, and implementing a lot of kind of automated strategies in an organization. Rashmi is also coming from more than a decade of experience. She's a test architect by profession and a very well versed with respect to various kind of testing, whether it's a functional or a non-functional testing. And she's really passionate about big data and analytics, future technologies. So really a warm welcome once again, Dimpy and Rashmi, to this API testing summit. And stage is all yours. Maybe you can start sharing your slide and take us through your topic.
Sure. Thanks a lot, Sumit, for that intro. Dimpy will be sharing this slide. Yeah.
Right. If one of you can share, and I can just confirm quickly if it's visible.
We can hear you.
Right. No, I was just checking. Yeah, your slides are visible. Yeah, stage is all yours.
Dimpy, you are on mute.
Yes, yes. Dimpy, you're on mute. Dimpy or Rashmi, like whosoever is talking. Yeah.
Yeah, Rashmi, you want to go ahead first?
Sure. Yeah. Like I said, yeah. Thanks, Sumit, for the intro. Yeah, I have around 12 plus years of experience in software industry and predominantly worked on big data and analytics, working as a test architect at Happiest Minds Technologies. Over to you, Dimpy. You're on mute.
Sorry. Hi everyone, I'm Dimpy. I'm working as a test architect in Happiest Minds Technologies. Rashmi is my colleague actually. And today we both, Rashmi and me, will be presenting about a very interesting topic, like how we can actually test MQTT messages where hardware meets software. So we'll be presenting a testing strategy on the same, and we'll also provide a good demo. Okay, so here's the agenda. So we divided the entire presentation into two halves. Like I will be taking care the first half, where basically I will cover why MQTT is a right fit in the IoT world, some of the key concepts related to MQTT, and how MQTT is actually different from HTTP protocol with the IoT use case, like IoT and MQTT use case. And in the second half, Rashmi will walk us through a testing strategy for MQTT clients and the broker, and she also will show a demo. Okay, so the moment we say API, right? So in a very plain word or in a layman word, what I can visualize API as, two entities talking to each other. Now, when I say two entities, right? So the two entities can be software and it can be hardware also when we step into the IoT world. So most of us are familiar with the software part, like we know how we can test applications, software applications which are connected to a server and give us some data. So in the IoT world, things are little different, right? So we need actually something, where devices or hardware devices can talk to a software application or vice versa. Let us take a very simple use case here. We want to protect our residential or official premises from COVID. That is a recent thing it's happening, right? So you might have seen application also are deployed in real time. So in this scenario, we basically need, at least bare minimum, we need a hardware which has a temperature sensor. And the temperature sensor should give us the detail of the temperature for each person who is actually entering into our premises. But that is not enough, right? So we also need somebody to receive that information. So we need another application to receive that information, and we need some features like real-time monitoring and taking action, right? If suppose no, the temperature value goes beyond certain limit, right? Suppose we have set the threshold at 99 and one person came into our apartment, his temperature is 100. So we want to take some action on that, right? So we want to send some alert to set of volunteers, or emails or SMS we want to trigger. So in that case, our application, right, our mobile application should have those capabilities. Now you see, like, we have a temperature sensor in one side, a device, and we have our mobile application in another side. So how these two diverse applications will talk to each other? That's where is MQTT comes into picture. It is a messaging protocol, as we all know. So it is a very lightweight messaging protocol. Now it is also ISO compliance with PubSub architecture. So this protocol will facilitate the entire thing for us. So for a smooth communication between the hardware and the software. Let's see some of the key features of MQTT and relate like how actually MQTT is a right fit in our use case. So why do we need MQTT, especially in IoT, right? The first point is it has small code footprint. Now, how that will help? If you see majority of these IoT devices, right, like sensors and all, they have very limited resources like RAM or CPU, or they are battery operated, right? Even they may have bandwidth constraints. So in this scenario, a protocol which has a very small code footprint will help. In MQTT, the size of the header is actually very small. It's just 2 bytes, right? And you can send a payload up to maybe 256 MB. But if you see in other protocol like HTTP, size itself, maybe 8 KB, right? So it depends on the, obviously it depends on the server. But if you compare HTTP and MQTT, you can see it is a very lightweight. So, and it helps us to come out with some limitations of these constrained devices. Next important thing is MQTT is a PubSub architecture messaging protocol. So what is PubSub here? So if you go back to my use case, right, I have demonstrated like I have a device and I have a another mobile client in other side. So device will actually send some messages and the mobile client should receive that messages. So in MQTT world, this is called publishing and subscribing. But all this thing happen via a centralized component, which is called broker here. So MQTT broker is the main backbone of the protocol. So what does how does this actually help? Okay, so this actually decouples the clients. It's very important to understand this point, because when the clients are actually talking to each other, they don't need to know each other. They don't need the IP address, they don't need the port, they doesn't even know anything about the clients, right? So they communicate via the broker. So that decouples the client and the different clients in this system. So how does it help? So when you don't need a lot of information, right? So again, your packet will be very light. That's one thing. Second thing is you don't need to be, sync with each other. So MQTT is a asynchronous protocol. So the device or the hardware and the client may not work with sync. Sometimes device may not be available, sometimes the client may not be available, doesn't matter here. The next thing is it supports multiple transport. So we can send the packets via TCP or WebSocket. So when we are connecting from a mobile device or from a hardware, right, you can use TCP. But suppose you have a web application, you can also use a WebSocket as a transport medium. Okay, so next, very important again feature of MQTT, it supports persistent session. So what does it mean and why do we need a persistent session in the IoT world? So MQTT sessions can last longer. Now, once the connection is established, you can even, depending on your design or implementation, you can keep the session on for maybe days, years. Even I have come across some use cases, even you can make it, last for years. And it is very suitable for unreliable networks. So let's understand this point from an example. Suppose you are traveling in a connected car. So you have some connected devices inside your car and you are talking to a broker. And you are traveling and in between just you came across a tunnel, big strong tunnel, right? So you went inside the tunnel and all your connections are lost. But as soon as if you have opted for persistent session, then as soon as you come out from the tunnel, you should be able to reconnect very quickly because your broker knows that you have a persistent session. So Rashmi will cover more on this in her testing strategy. Next is bidirectional communication. Okay, so bidirectional communication, what does it mean? MQTT is actually not a unidirectional stuff. Both the publisher as well as subscriber. So here, what when I say publisher and subscriber, I'm actually referring to the MQTT clients. So they can send or receive at the same time. So say suppose in our use case, right, we have a hardware device, right? So that device is continuously sending the temperature data to a mobile application. Now, suppose in between one of the hardware device, something went wrong in the device and it started sending error code, right? So without even going near to the hardware device, how can we control it, right? If the hardware device is actually sending only the temperature messages and it is only in the publishing mode, so you will not be able to control the device. But if it is also subscribing for a command, listening to a command, right? So like on, off, reboot, right? Those kind of commands are actually very, very important in an IoT world. Suppose you want to reboot your hardware, you want to restart it. So you should be able to do application. And in this case, the mobile application should be able to restart the device if something goes wrong in the device, right? So that's what I'm talking about, like a bidirectional communication. That is also important when we actually have hardware and the software together. Another important point is reliable message delivery. So MQTT has something called quality of service. It has actually 3 quality of service: QoS0, QoS1 and QoS2. So QoS0 is just send a message and forget about it. But QoS1 and 2 ensure that the message has been delivered. Right? QoS1 it is a single level of handshake will happen, and QoS2 and double level of handshake will happen. Again, Rashmi will cover more on the quality of service in her test strategy. So now we know, like, okay, why we actually need MQTT in our IoT world. Like, we can actually relate the application or the use case we have taken and why we have chosen MQTT for machine-to-machine communication. Let's see some of the key concepts. We are already aware of some of the terms, but yeah, few more are there. So we know now the concept of clients and the broker, right? So in MQTT world, all the applications Whether it is a hardware or it is a software, we will call it as client. And we have a server, which we'll call as broker. So how does actually broker identifies the clients, right? So all the clients will be having their unique client IDs, and once the clients connect to the server, it can use credentials also if you want a secure connection. And once the all the clients are connected, they can start publishing or subscribing the message. So what does publish means? Publish means nothing but you are sending the message to the broker, and subscribing means you are actually receiving the message from the broker. In our use case, the hardware temperature sensor will be publishing the temperature values to the broker, and the mobile app will receive the temperature, and it will perform actions if some business rules are triggered. Another important concept here is topic. So topic is nothing but a string in terms of implementation, and the topic, the broker will use the topic for filtering the messages. For example, the temperature sensor is actually publishing a message on topic moisture, for example, right? So the clients which are subscribed to that topic moisture only will receive that information. So the broker will make sure whatever messages are delivered, it is receiving from the publishers, it will go to only the correct recipients. Again, topic is have a tree-like hierarchy. You can, for example, you have one device in your main gate and main entry gate, and one device you have deployed in your exit gate, right? And you want to monitor both the gate. So you can set a topic like entry gate temperature, then exit gate temperature, and the subscriber will listen to those topics, and once it gets information, it can act upon. So these are the main actually components where you can see how MQTT works. So we have clients, we have broker, we have topics, and the actual message, right? So we will send the actual message under the topic. How we will send the messages, that Rashmi will be sharing in our testing strategy as well as in the demo. So yeah, so as I told before, bi-directional communication is possible here, and the subscribers can actually control the publishers if publishers are also subscribers. So here is few points where we can compare between HTTP protocol and MQTT protocol. First feature is the purpose, right? So we all know HTTP is well suited for documentation transport, but MQTT is mainly for messaging. If you see, when we want to transport some documents, right, the size of the payload will be higher. So because you may need to transfer images, text, videos, lot of things. But MQTT, the payload will be always mostly like smaller, so we can very well use MQTT for messaging purpose. Another important thing is here is like suppose you are receiving some document, some information via MQTT. The order of receiving the packets may not matter. In a web application, for example, right? So loading of images, you have some 100 images. The loading of images order doesn't matter, right? So once everything comes, we visualize it. But in case of MQTT, yes, order matters based on your use case. For example, suppose you are having a chat application, right? So if you are using MQTT as a protocol, then the order the messages comes matters here. Next is the architecture. As I explained before, MQTT is a publish and subscribe architecture, but in HTTP is, we all know, it is a request and response architecture. Yeah, we need a centralized broker here in MQTT, but HTTP we don't need a broker. So in terms of power efficiency, yeah, MQTT is again a win here, and HTTP it is average because, as I explained before, MQTT is a lightweight protocol. So quality of service, yeah, HTTP doesn't have any specific quality of service, but MQTT guarantees the delivery of packet using the quality of service. In terms of fault tolerance, and HTTP again, yeah, server or load balancer is the single point of failure, and MQTT again, broker, or if you're using load balancer, will be the single point of failure. In very high level, this is the comparison between HTTP and MQTT. I think I have covered, like, the very basic concepts about MQTT, how the entire thing works. I have also covered a use case where you can relate all these concepts. Just a recap, like we have a hardware device, we have a mobile application which are connected via MQTT, and the hardware will publish temperature messages. The mobile device will receive those messages and act on if anything goes wrong. Over to you, Rashmi.
Thank you, Dimpy. Yeah, my screen is visible.
No, not as of now, Rashmi. If you can share, please.
Okay. Now?
No, still no.
Okay. Even now it's not visible.
I see you are a presenter, Rashmi, so you should be able to share. Or maybe like if slides are handy with Dimpy, she can share and you can go through it.
1 second, let me try it again. Oh, it's still not visible. It's very unfortunate.
No, it's not visible. I hope it is not only me. Dimpy, it is same for you, right? Okay.
Let me share the slide.
Now we can see the slides.
Okay.
Yeah, slides are back. Yeah.
Yeah, sorry for that glitch. I'm not sure what happened.
No worries. Yeah, please go ahead.
Yeah. Now let's see testing MQTT clients and broker. We have broken down it into different, like functional reliability testing, performance testing, and security testing. Now let's get into the functional testing aspect of MQTT. Like Dimpy explained, here we have something called a publisher, a subscriber, a broker. So how are they talking to each other? So it's purely because of connections. So connection establishments is the key here in order to perform a test. Your connections can be successful, unsuccessful, network could be an issue, your user credentials can be incorrect. Based on the status codes, you can validate whether your connection is successful or not. MQTT has another concept called last will testament. When a publisher tries to send a message, it makes a connection with the broker, but it can also send a last will testament or a last will message in case the publisher or the sensor, the device that goes down abruptly for whatever reasons could be, maybe a network or a bandwidth issue or the batteries issue. Anything can happen and it can end abruptly. So it wants to send a message saying that I have exited abruptly. So that message will be broker will be waiting to see if the publisher is available. If he is not available, that it ensures that all the subscribed clients are notified that this last will message, whatever the publisher had sent it, will be sent to all the subscribed clients. So that is one good feature where we can see that whether the publisher is available or not. If it's offline, then you get to notify. Then comes topic subscriptions. Like Dimpy explained, topic is a string. Based on that string, the MQTT broker decides to whom this packet should be delivered to. There are different ways of topic subscriptions that you can do. It could be a single subscription or a multiple subscription or a shared subscription. Single is only one topic you subscribe. Multiple is multiple topics you would like the client likes to subscribe to. And shared is a new concept wherein there is a group. You have multiple clients there, but subscribe to a single topic. Why do we do that? In order to avoid the client to be overwhelmed. There is a lot of data that is incoming, and if there's only one client, it could be overwhelmed. In order to avoid that and maintain a load balancing, the shared topic subscription is a new feature that has been available in MQTT. Then what are the other areas we have to cover? Notification and alerts. Based on all these data that we receive, we need to set some alerts. Maybe like in our use case, it's been mentioned anything above 99 and 100, an SMS to be sent to the volunteers that a person with this threshold has been seen. So you'll have to ensure whether your notification and alerts are covered. It could be a simple SMS or it could be an email. Then comes the dashboards. We have received so much of data. Finally, what do we do with all this sensor data that we receive? We build dashboards, we analyze, so we do perform analytics on top of it, whether these analytics or the reports that are being built are correct or not. So you validate even the dashboards. Coming to the reliability aspect, like Dimpy covered in her slides, QoS, which is quality of service. In MQTT, this is one of the best feature it has, where you ensure the messages are reliably sent to the subscribers. There are 3 levels, 0, 1, and 2. In 0, the publisher sends and forgets. It's called fire and forget. It fires the message and forgets it. It does not wait for an acknowledgement. There could be a use case where it's okay to lose some data. You keep getting sensor data every 5 seconds, and if you lose few of the messages, then it should be absolutely fine. Then comes the level 1. In this, this is at least once the message is delivered. When I say at least once, then there could be a chance of duplicates. It can send multiple times. The publisher sends the message and then waits to get an acknowledgement. If it does not get an acknowledgement, it retries and sends it. So in this, the message can be sent once or more than once. When it sends or retries again, it sends with a flag called duplicate. So your applications need to be built in such a way, if it accepts duplicates, how do you handle those duplicates? Most of the design or the architects consider level 1 as safe because they receive the messages and the duplicates are acceptable. Then comes the level 2. In level 2, this is like a costly affair here because there's a multiple packet exchange happen, and here only once the data or the message is being sent. These are purely the QoS. Then we have a persistent session wherein the broker tries to maintain the status of the client. Here it ensures that whatever subscriptions, topics, what is the client ID, what is the QoS level, all these persistence session will be maintained if you set this clean session flag as false. Then we have something called retained messages, wherein the publisher keeps sending the messages, but when a new subscriber gets subscribed, it has to wait till it receives a new message. In such scenarios, you can have a retained message where it says maybe any new subscriber subscribes to this topic, then let this be the first message that it has to go. This ensures that at least a message connection is happening successfully. Then comes the performance aspect, wherein we have latency, what is the delay that we see, and it also depends on the payload. You have a small byte of data or a huge JSON payload, or accordingly, you'll have to set your requirement and perform the load test over there. Coming to message throughput, we have fan in, fan out, and one-to-one. In fan in, you have multiple publishers and single subscriber. In fan out, you have very few publisher, but you have large number of subscribers. And in one-to-one, it's only one publisher, one subscriber. So accordingly, you can do a load test of your broker and put a benchmark like how it is performing. And you can have something called number of subscriptions a broker can have, a number of topics it can subscribe to, what is the publisher rate or a receive rate. These are the basic metrics that you would like to capture as part of the performance. Then coming to the security. Security in itself is a wide concept in MQTT, but here it is purely just an authentication and authorization using username and password. If your user credentials are incorrect, then definitely your connections will not be authenticated and you get an error message. This is done at the application layer. There is another transport layer where you can authenticate by having the SSL certificates, and then you can get rid of this username and password credentials. At a high level, the basic testing concepts in case of an IoT-based application using MQTT is what is this. Having said that, there are lots of challenges in testing these kind of applications. Could be a hardware, a firmware, when a device gets updated, your network, your Wi-Fi, bandwidth, everything needs to be considered when you actually perform an IoT-based testing. Without wasting much time, let's get into the demo. We have considered MQTT public broker. Then we have a dashboard and an Android app which serves as the publisher, and we have a IoT panel app which serves as a subscriber. And then we have automated all this using a Eclipse Faho MQTT Java client. Is my screen visible?
It was visible.
No, it's not.
Can you try once more?
Is it fine now?
No.
This is important. Okay, how about this? Even now it's not visible.
Mm-hmm. Can you send me the video? I can play it from here. You can exit the Teams and join back.
Yeah, can I just join back, Sumit?
Yeah. Maybe I can take some quick questions if anything is there. Sorry for the glitches.
Sumit, are you around? Hi, Dimpy, this is Deepti. Okay, Sumit is not able to unmute himself. Can you share your social handles, Dimpy? A few people are asking to connect with you. I think you're Dimpy, you're on mute.
Yeah, I will share the slides again.
Sure.
This is the summary of the demo actually, which Rashmi will. So these are the social handles for both of us.
Also, for those of you who are looking to connect with them personally, I think on the API Summit, you can connect with them on LinkedIn. Their LinkedIn handles are there. There is only one.
Reference.
There is one question, Dimpy. Sessions are maintained. What is the use case for this?
Persistence session, right?
Yes.
Okay, so I think I explained it. So suppose your connection is lost abruptly in between, right? So the use case I was talking about is a connected vehicle. You were just going somewhere and suddenly you got a tunnel. So when you are inside the tunnel, you lost all your connections. But when you come out, right? So instead of again connecting back to the broker and sharing everything from scratch, you can if you have retained the connection, then it will speed up the process again.
Is my screen visible?
Yes.
Okay. Sorry for the glitch. Do I have another 3 minutes to show the demo?
Yeah, you can go ahead. There's 1 minute, but that's okay. We can just go.
Sorry, yeah. Okay. So this is one of the publisher wherein a temperature gun wherein we subscribe to a topic, temperature topic, and whatever temperature this the sensor sends it goes to the subscriber client, and here accordingly the gauge gets. As we said, we have mentioned that 99 and 100 is a threshold wherein we want to alarm. So now if you can see, it is changed to yellow. Similarly, now anything above 100 is quite alarming, so we make it as red. So this is how the subscriber gets the messages it has registered to a topic from a publisher. You can see we have another client called light, but there is no impact on that light topic. That's how MQTT differentiates the topics. It's a string, but it differentiates. Now if I on the light gets on, but there is no impact on the temperature gun. That means the broker filters the messages, whatever it receives, and accordingly it does it. You off the light and it automatically turns it off. These are the two Android apps that we have used as hardware. One is a sensor and one is a mobile device, which is taking as a consumer. Then we have a WebSocket client, which is a public broker HiveMQ. We have used this. And here, if you see, well, that was on the TCP layer. Now we are doing it at the WebSocket layer. So you establish a connection with the broker, and then you publish. Then you start publishing. Now it could be at entry gate 1 or 2, wherever you want to publish that message. You publish it. I'm just moving a little fast here. Now we have a subscriber, and you can see we are using a wildcard. That means either entry gate 1 or entry gate 2, whatever could be the gate, but I want to receive the message. So you can use these wildcards in your topics. Then without even publisher publishing any message, this is what the message came in. That means these are called retained messages. When a new topic gets subscribed, automatically whatever is the retained message was set by the publisher, it receives. This is what retained messages concept in MQTT is. Now, if you don't turn on this retain message flag, that means it's a normal message. Whatever is your subscriber, it keeps getting the messages accordingly. Not only here, since we have connected to the same broker, you can see I'm just forwarding it. So now I have published 100 as a message. Now you can see that the other client that we had is changing the gauge according to whatever the message was sent by the publisher. So all this is done by this public broker that we have used in our demo. This is purely the demo that we wanted to demonstrate, wherein the publisher publishes the messages, the broker filters the messages based on the topic and sends it to the corresponding subscribed clients. Using Eclipse Paho client, we have automated the same. In MQTT, we need to write two classes, maybe a publisher client and a subscriber client. In publisher client, you specify what is the broker ID, the broker you want to connect to, the user credentials, the topic details, what are your connection options, all these will be specified, and then you make a connection. Once this is done, you will have your subscriber client. There also you'll specify what is your broker details, which topic you want to register to, and how do you want to receive the messages. Now let's try to publish the messages. Now if you see here, we are trying to publish a message using the publisher client. Every 2 seconds we keep on sending the messages. Now you see it has been publishing to this topic, and these are the message 100, 101, 102 is going. Now let's go to the subscriber. Subscriber client got the first retain message, and thereafter whatever messages the publisher is publishing, it is receiving it. Not only here, since everything is on the public broker, you can see the WebSocket client where we had already done. You can see all this data being coming. That's pretty much on the demo. And just want to summarize quickly, we have a MQTT client, which is nothing our Android app, which is publishing the data. And we have a HiveMQ broker, which is taking the data from the publisher, and sending it to the subscribe clients. One is a WebSocket client and the other one was our IoT MQTT panel subscriber client. That's how the broker filters the messages and transfers. This is how the IoT devices actually work using MQTT protocol. I'm extremely sorry for sharing the time.
No problem, no problem. Thank you
Now
so much for that interactive and very in detail demo and explanation, Dimpy and Rashmi. There were a few glitches, but then yeah, that's fine. Yeah, thank you so much.
So now there's a call to action is
Your voice is breaking, so I'm not able to hear much. Audience, we'll be passing on this link for the feedback for Dimpy and Rashmi's talk. Please fill in this. And thank you so much for coming up with that topic and giving the demo and the explanation in detail, Dimpy and Rashmi. Quick.
One thing, the audience to know that you can explore MQTT, you can use some of the cool client apps that are available in the Play Store and the iOS Store, and then come up with your testing mind maps as an action item from whatever we have demonstrated. It looks very complex, but it is actually, when you dive into it, it's really cool and good to know about it. These are the references that we have used, and these are now open for question.
Great, Rashmi. Probably we can have these things, have the references put on the chat. The audience can actually use those to dive into the topic more.